Hi, this video is to talk about determining sample size for certain margin of error that we want. Okay, so before I dive into the slides, let me show you a nice applet in MindTap. So this is MindTap, our book. You can go to chapter 8. Chapter 8, there's many options. You can go to exploring statistics. Here, this exploring statistics has many applets. They're very interesting for you to explore and understand the concepts. I strongly suggest you to use them to understand the concepts. I don't have time in the videos to show all of them, but I strongly advise you to do that. But let's take a look how the sample size influenced the confidence level. Okay, so I select this one. This is the desired margin of error for a rental cost, and the margin of error is determined by the standard deviation, remember, and the sample size. So suppose a project director designed a survey to estimate the mean daily rental cost of medium-sized automobile. So based on a previous study, the director knew that the mean rental cost was $55 and a reasonable planning value for the population standard deviation was 9.65. The graph below shows a 95% confidence interval using 9.65 as the planning value for the standard deviation. So here is at the center we have 55 as the mean rental cost, and this would be the 95 confidence interval if my sample size has only 5 observations. So you see that the confidence interval varies from 43 here to 66.98 here. Look what happens with this confidence. You see that this confidence interval is pretty wide. It pretty much is everything. All values are in here. So it's difficult to make a decision with so much variability. So if you are a director of a company and you have to try to estimate what's the mean daily rental cost of a medium-sized automobile, it's hard to make a decision because it's everything from 43 to 67. It's not like something that is okay, is a narrow value, but that's because our sample size is too small. If we increase the sample size, look what happens with the limits. They become narrower, so it becomes smaller. So it's much easier for a manager makes a decision with information about the rental cost, the mean rental cost for automobiles varying from 51 to 58.9. So it's much less variability. You're more precise, so you can keep increasing the sample size and the confidence keeps decreasing. So that's the effect of the sample size on interval estimation. That's the reason we have this set of slides to talk about that. So what is the sample size we need for a given interval estimation if we have a specific margin of error? So we're going to call the desired margin of error as letter E, is the amount to add and subtract from the point estimate, the sample mean or the sample proportion, to obtain an interval estimate. If a desired margin of error is selected prior to do the sampling process, prior to collecting the data, let's say I want a specific I don't want too much error. I want a specific margin of error, but I haven't collected data yet. So I can plan the sample size necessary to satisfy this need. So this is just a review. Margin of error is the z alpha level divided by 2 multiplied by the standard deviation of the sample mean given by this part of the formula. So and if we play with some arithmetic here, some algebra, if we do some algebra, then the necessary sample formula becomes the z alpha level divided by 2, the z score squared, and then the population standard deviation square, and then the error that you want squared. Okay, let's take a look at one example here, then I go back to that slide. Cost of renting automobiles in the United States. A previous study that investigated the cost of renting automobiles in the United States found a mean cost of approximately 55 with a standard deviation of 9.65. Suppose the project director wants to estimate the population mean daily rental cost with a 95% probability, and the sampling error, so the margin of error, is 2 or less. How large a sample size needs to be? So this is the formula, and we know that the margin of error given in the problem is 2. So E is equal to 2. I know that the z-score for 95% is 1.96. I know that the population standard deviation is 9.65. If I plug the z-score here and square, if I plug here the population standard deviation and square, and if I plug here the margin of error and square, and I do all this math, the sample size is 89.43, which is 90 people, okay? Or 90 observations, 90 cars. So the sample size needs to be at least 90. So you can do that by hand, or you can do that by Excel. Very, like, that's straightforward. I'm going to just go back to this slide here. So you see that to compute the sample size needed, let me go back to the formula here. The sample size, the necessary sample size, I need the population standard deviation. Sometimes I don't have the population standard deviation. So here are some guidelines when you don't know the population standard deviation. If you don't know the population standard deviation, you use a preliminary or planning value for that. How we do that? We use the estimate of the population standard deviation computed in a previous study. If you have a previous study with a previous population standard deviation, if you don't, then you can use a pilot study to select a preliminary study and use the sample standard deviation from that study, which means you do a sample and you can use the sample standard deviation, or you use the best guess for the sample, the population standard deviation. Okay. What else here? Now we can move to determining the sample size for a population proportion. Again, we have the margin of error denoted by the letter E. And remember from our videos on chapter 8, the margin of error for population proportion is the z-score and the standard deviation of population proportion. Okay, so this is how you compute them. And if you do some algebra here, then the sample size is going to be equal to the z-score squared multiplied by sample proportion multiplied by 1 minus sample proportion divided by the margin of error squared. Okay. So let's take a look at one example here. Suppose the survey director, remember the survey of women golfers from our video about population proportion. Let's say the director wants to estimate the population proportion with a margin of error of 0.025. That's the letter E in our problem. That's the margin of error. 95% confidence is our confidence level. I know that the z-score associated with 95% is 1.96. How large the sample size should be? So I know that the margin of error is 0.25. I know that z is 1.96. The sample proportion is 0.44. I plug the numbers into this formula and I have the answer, which is 1,514 people. Because I cannot have half people, then we have to make a decision if we want to add, or if you want 1,514 or 1,515 people answering the survey. Okay, that's how you do it. And similar to the other case, if we don't know the population proportion, what we can do is that we can plan using a planning value based on the sample proportion from previous studies or similar units, selecting a preliminary sample using the same proportion from this sample, using judgment or best guess, or simply using 0.5 as the proportion. 0.5 is maybe in the case of you don't have other the proportion, then you can use 0.5 as the most conservative value. Okay, and that's it. You plug the numbers and answer the problem. That's all.